Okay. Okay, here we go. We are going to talk about 5.4, and this is on reflections. In my opinion, reflections are easier than translations, but opinions are very different here. Geometry is the hardest class to teach because I can't make you see something, right? So if you think this is harder, you're going to have to advocate for yourself because maybe I'm not teaching it good enough because I see reflections easier. Okay? So these are the words we're going to need to know. The first word is equidistant. Okay? Has some roots you might recognize. What's equa look like? Equal. And then you have distance, which means what? Like how far things are apart, right? So if things are equidistant, they are the same distance from. Okay? Now, reflection. What was the common word for reflection? Like the fancy, not the fancy word. Flip. It was, what did you say? Mirror. Mirror? I didn't hear it because I had the head pods on. They said flip, and that's usually what I think of. Mirror also works. So this is basically, I kind of like the idea of mirror here, but you're going to see why there's a little issue with that one in a minute. The line of reflection is where the mirror would be, or the line it flips over. So it's the line you flip over, or where the mirror would be, but the mirror thing I'm going to show you has one little issue that will come up later. Correct, because I'm trying not to talk super loud. I do talk different with this on. Oh, they like it? Yeah, so, okay. Right, my energy is lower because I'm trying to not blast your eardrums. Okay, midpoint. Midpoint, just what you think it would be. It's in the middle. Perfect. It's the point in the middle. It's the point in the middle. Somebody, I liked what somebody just said there. Somebody used a math word. They used the word median, I believe, which is actually, if numbers are in order, it is the exact middle number. So whoever said that was wonderful because that is a statistic idea that you remembered. So gold star. And we already said what reflection is. That's the flip. Okay. So we're talking all about the flipping stuff today. Do not flip anybody off, though, because that is not what we're talking about. No bird flipping, just point flipping and shape flipping. Okay. Now, if I gave you a bird to reflect, you are welcome to reflect it, but it is not going to happen. Okay. Just so you know. Okay. Now, here we go. Do you see all these K's? There's 4 of them. Remember the words image. You don't have colors, so this is going to be bad on your worksheets, guys. So you're going to need to put orange here. Just put orange on top of this K. It says, which image, which that means new guy. Remember, what's the word for the original? Pre-image. Somebody said it and it's beautiful. Which image will be a reflection of this guy? Okay, so I want you to think from this orange K over here to the purple. Was that a reflection? Is that a flip? No, that's a what? That's a translation. I loved how you use the math word. It's a slide. Okay, how about this one? Yes, right? It flips right over that X line. And what about this one? It is by itself. Does anybody see what it actually did? Did someone say it? Did they say turn or did they say rotation? Ooh, use the math word, even better. This one is a rotation. This one is a translation. This one is a reflection. They want to know which image it is. So it is, what do they want us to do here? They want us to say 4 or they want us to circle it? Yeah, you could just circle it because you have a copy of it. Or those people who are writing their own notes at home, you could kind of try to do it if you want. Like if you flip it over, it'd be kind of like, that is so bad. That does not look anything like it, but you get the idea. Okay, so what line did it flip over? Because we talked about that, the line of reflection. It flipped over this X line. Does everybody see it? It just hopped right over it. So now let's look at more of these lines of reflection. The line of reflection is, it has to be between the pre-image and its image a lot of times. It'll be in the middle of it. the midpoint almost, okay? So what you have to do is you have to find an original, and we know this is the original because there's no primes, and this one is the new guy because there's a prime, and C, like count away. Like you have to split the distance. Together, they're 2 apart. Does everybody see that? But if you split that, you can tell where the line of reflection would be because it would be the midpoint of that. So this line of reflection here is at, and the equation of this line, oh, this is sad. Do you see that blue spinning circle? That could mean bad things. Okay. The equation of this line, and they might ask you stuff like this later. Oh, little glitchy too. Oh, little glitchers. Bad stuff's happening. Oh, blue spinning circle. Why? This is not seeming. This is, look at that. Okay. I'm not, it's 7 equals what? 7 equals what? I'm going to try this again. Notice, everybody, I'm still a very happy little dinosaur here. All right, it's y equals, can you guys write y equals 4? It happened. Y equals 4. That is the line. If it's an up or down line, it's going to be, I'm a horrible liar. I am a horrible, horrible liar. It is not y equals 4. Does anybody know what it is? Where is it going through? It's an x equals 4. I'm so sorry. Mine obviously was very neat as well. I don't know what I'm going to do, guys. Okay. I'm not going to go cry because people have been making fun of that lately. Okay, next. Let's see if it clears itself out. I might have to restart my Active Inspire. So look, I just talked to you about that. Look at this reflection. Everybody sees it? Do you agree that it flipped over the X line? Every point is the same distance from that line to its match. So C is 1 away. C prime is 1 away. Notice B. How far away is B from it? 1, 2, 3. How far is this one down? 1, 2, 3. Does everybody notice that? A is 1 away. A is 1 away. So the distances don't have to be the same for all the points. They just have to be the same to their match. So A is the same far away as A prime. B is the same distance away as B prime, and so on. I am going to have to restart my Active Inspire and see if that helps my situation here. Not time for a nap. Okay, go ahead and look at this next one. I actually might be able to use this notation stuff too. I'm going to see if it lets me do that. I'm so sorry for the people watching the video, but this is what it would be like if you were in class. So, okay, let's try this instead. I'm going to see if I can do it with this, guys. Okay, next. That's true. Okay, guys, I need your attention again. This was my fault, not yours. Okay, take a look. This one is reflecting over the y-axis. I want to talk to you about that distance idea again. Look, K, 1 apart, 1 apart. J, 2 apart, 2 apart. Does everybody see that? They're equidistant. This is 1, 2, 3, and 1, 2, 3. So it's a way to tell where the new points go. If they only gave you 1, you could count over to get to the new point. Now, some of you might not have liked how I just did that because I'm actually kind of sad I did it that way. Because did you see how I started at the J prime instead of the J? I probably should have started at the original and then gone to the line. But it really kind of doesn't matter because they will be equivalent. Okay? Let's look at these. We have some questions to answer. Okay. Are your triangles numbered? Yes. So the color isn't going to matter. Triangle 1. So does everyone see triangle 1? It is the image. What's the word for image? Image is the new guy. So triangle 1 is the new of triangle 2. If that's the old, what did it reflect over? Beautiful. It reflected over the y-axis to get there. There is a box, but there's probably not enough space. So y-axis. Okay? Now I'm going to erase that because now it says triangle 2 is the image. So that means triangle 2 is the new guy of triangle 3. So that is the old guy. If triangle 3 is reflected over what axis? That is flipping over the x-axis. Okay, everyone try to do that last one on your own. If you take 4, triangle 4, and you go over the y-axis, what triangle are you going to be at? Take triangle 4, go over the y-axis. Yes, what triangle are you going to be at? You guys see it? It has to be triangle 3. Okay? Everyone kind of seeing it a little bit? All right, we're moving right along. Okay, this time we have to find the reflection line. Now, again, I don't want, usually we're patient, but today we need you all to be with me. Usually, some people can see it right away. Others of you are going to have to count it out. If you see it right away, just go with it and kind of block out what I'm saying, because some of you are going to think this is easy and you'll see it. Okay? Do some of you see where the mirror would need to be right away? Okay, so draw it in if you want to. Those of you who cannot see where it needs to be, you go to A, which is here, and A prime, which is here. And you say, how far apart are they? They're 2 apart. But they are supposed to be equal distant from that line. So I would have to cut 2 in half or find the midpoint, and the line will be 2 divided by 2, which is 1 away. So that means 1 away is where the line should be. Again, some of you might just see it. Okay? What if you didn't pick A? What if you would have picked B? Because we talked about that. I kept picking different points than Tayton was picking. Yeah, B is, thank you. 1, 2, 3, 4, 5, 6. Perfect. It's 6 apart. So then you would have to take 6 divided by 2. It's kind of glitchy the way it does that, isn't it? And that's going to be 3 away where the line would have been, and it still would have ended up being at the same spot. So where is the reflection line? What is that line I just drew? And be careful, don't be stupid like I was on the first one. What line is it touching? So it's going to be x equals what? Somebody said it. 2, right? That's where it goes through. Did somebody say 2? I don't know. Did nobody say 2? Yes, x equals purple. 2. I'm sorry. Okay. Yeah. People in the video think but you guys do too. A lot of people think I'm insane. The audience is concerned that you guys will think I'm a little crazy town, but know that it's a good kind of crazy. Like there's scary crazy and there's she keeps it interesting crazy, and that's usually what I'm trying to go for. Okay? Thank you. Okay, next. Everybody, look at that. I just erased it and it came back. Did anybody else see that? Okay, can everybody try? No giggles. We got some sillies here. I need everybody to look at this next example. Mine is orange and green. It doesn't really matter though. They want to know where the reflection line would be between these 2 figures. Sketch it in if you want to first. That's what I prefer to do, is draw in where that mirror would be. The flipping line. Okay? If you can't see right away, then you need to do the stuff I told you, okay? You need to find a pair that matches. And they're not labeled either, which makes it tricky. You don't have a grid? Oh, that makes it hard. I'm apologize. My notes I copied. I'll darken that next time. Okay, it's not there at all. So can you see mine? Can you look off of mine? This will help you. Okay. Okay, the middle is -2, and it's going this way this time. Now, if you didn't see it, because I'm going to stop right there, you could have counted, but you guys can't count because you don't have the grid marks very well on your paper. Those are 2 apart. So if you take the 2 and you divide it by 2, the line needs to be 1 away, and that's where that line will be. It's not that bad. Some people see it quickly, but you need to write the equation. Be careful. The trickiest part of this will be if it's an x equals or y equals. Which one is it touching? The y. It's touching the y, and where is it touching the y? It touches the y right here at where? -2. Okay. Did you put x? I know. I know. If it almost can tell you, if you can find the nice point, Chase, and you just kind of put a dot there, it might give you the answer. -2, y. Y equals -2. Okay, kind of think of it that way. That is definitely the hardest part. Okay, now, the next thing. Do you guys remember the codes when we did the translations? Okay, well, I'm going to remind you real quick. This is so bad the way it's so slow with the writing. Should I try to open up the Active Inspire again? Or do you think it's just the slowness of everything? It might just be slow no matter. I am going to try this just because it's annoying to me. I'm super sorry to the people watching this video. Just fast forward. The kids in person can't fast forward, but then they start talking and then I start getting annoyed with them. And it's a very sad story for a lot of people. Mostly sad for me. It's the most sad for me. Yeah, things are a little different when I'm recording. They don't like that. But we're making good progress. Let's see if this fires up here. One more second, looks like. I'm really sorry, guys. This isn't. Do you think it's the computer being slow? Okay, we think it's an internet problem. Yeah, it's still not firing up. I don't know what to do. Okay. We're gonna try. I don't know if it'll fire up or not. And now it probably won't let me do anything because it's waiting for this. Here. Close it. No. Wait. Let's try that. Yeah, it's not gonna do anything. Okay, guys, we're gonna try to see if it will let me write on the side here. Okay, here's what we did for translations. We wrote the code. The code looked like this. It looked like X comma Y. Don't write this, just listen. I know, I appreciate it. Oh my gosh. X comma Y. And then there was an arrow. And maybe it said X plus 2, Y minus 3. Okay, do you remember this now? That was the code. And that told us that the X value went 2 to the right and the Y went down 3. Okay? Now, with reflections, we're not moving, we're flipping and stuff. So there are certain codes that only work for 3 special lines: the x-axis, the y-axis, and this line y equals x, which is really kind of tough to see. Okay, so I want you to look at these 3 dots here. Does everyone see the 3 dots at the bottom of the screen? Okay, A is the original. I know A is the original because there's no prime. If I go from A over the x-axis to A prime, look what happens. I want you to write this down. You're at 2, 3, and it goes to, where's the new point? 2, -3. So I want you to look at those 2 points. If this is x and y, if that's x and y, where is my new point at? If nothing happens, do you remember what we put? If it stays the same? We didn't have to put the 0, did we? Right, so we just put the x. So xy turned into, what happened from the 3 to the -3? How did that change? And it wasn't a slide. It went down for sure. But what if it was at 4? Where would the new point have been? Wouldn't it have been at -4? If it was at 1, wouldn't it have been at -1? So do you see that the only thing that changes, please listen, the only thing that changes is the sign in front of it. So instead of y, the new point gets a -y. It is weird. Now, it's weird with the code, but you know what's funny about it, Hunter? Without the code, you all could have got it right. If I said, hey, take this point, 2, 3, and reflect it over the x-axis, you know what you all would have done? You would have just counted 4 down and you would have got the answer right. But if they give you a code, I need you to be able to read it and understand what happened. That is the problem. They make it a little more complicated than it needs to be. Okay? So let's look at the next one, the y. Start at A. Does anybody think they already kind of know what's going to happen here? Hold on. You start at A, start at the original. A is at 2, 3. Where is it going if it goes over the y-axis? -2, 3. Does everybody see how it goes to this point? And Hunter said 2 because Hunter was just counting. Now, so what would the code be? And I'm out of space here, guys. You're going to write it underneath it. I have to write it up above because I'm out of space. Okay? It's XY. And where is it going? From here to here. What changed? It says positive. What's this one? This is a -x. And did the y change? The y stayed the same. So -x, y. So what the code is saying is if you reflect over the x-axis and you don't want to count or your graph paper is crappy, what you can do is say, okay, I have this code. So if I just change the sign of the x and keep the y the same, that will be the new point. When would you want to do that? Only if you did not have the graph paper. Or the graph is huge. Good call. If the graph was huge. Okay, I got to try one more time to get rid of that Active Inspire thing.